Dear students, welcome to Royal Palace PU College online classes. Dear students, in this particular class, we shall continue with our problems related to our mutually exclusive, that is nothing but our independent events and multiplication theorem that we were discussed in the previous class. And also in the dear students, in the previous session, that is we were already started with the topic that is exercise number 30.2. Today in this class, let us continue about this particular exercise. Okay dear students, now let us move on to the first one, that is if the events A and B are such that P of A is equal to 1 by 2, that means probability of A is equal to 1 by 2, probability of A union B is equal to 3 by 5, P of B is equal to small letter p. Here we require to find the small letter p value if first one A and B are, if they are mutually exclusive. Mutually exclusive means what? A intersection B will be null set here. Okay, let us start with the first one, that is A. If mutually exclusive, that is if A and B are mutually exclusive, then dear students, P of A intersection B equal to null set we have. Null set, that means A intersection B null set means probability of that null value will be 0 here. And also we know that, dear students, we know that P of addition theorem, A union B is equal to P of A, okay, plus P of B minus P of what we have, A intersection B, according to addition theorem. Here A intersection B value is 0, okay, then plus B, probability of B value is small letter p, that we require to find here, okay, and then P of A value, that is nothing but here 1 by 2, and A union B value will be 3 by 5. That implies here small letter p is equal to 3 by 5 minus 1 by 2. Okay, now cross multiply, that is 6 minus 5 divided by 10, and the value will be 1 by 10, and that is nothing but a required result of P here, required result of P when A and B are mutually exclusive. Okay dear students, now let us begin with the next one, that is independent events, that is B, independent events. Independent, that implies P of A intersection B equal to P of A into P of B, dear students, that we had learnt in the previous class. Now here, what is the formula here? We know that P of A union B, okay, equal to P of A plus P of B minus P of A intersection B here. Now here that is nothing but P of A union B equal to P of A plus P of B minus A intersection B means P of A into, dear students, P of B, because A and B are independent events here according to the given data here. Now all the values we are knowing, P of A union B, that is nothing but here 3 by 5, P of A, that is nothing but 1 by 2 plus small letter p minus of P of A value, again it is 1 by 2, and P of B is small letter p. Here we can observe that P minus half P, that is nothing but half P value will have 3 by 5 equal to 1 by 2 plus 1 by 2 P, that is 1 by 2 half, 1 minus half, that is half only. Now here easily we can find out the P value, that is nothing but 3 by 5 minus of 1 by 2 equal to 1 by 2 into P. So what we get here, that is 6 minus 5 divided by 10, that is nothing but here 1 divided by 10 equal to 1 by 2 P. That implies P value will be 2 by 10, that is nothing but 1 by 5, and that is nothing but our required very simple result. If you are cross multiplying 2 here, 2 by 10, that is nothing but 1 by 5 result. That was a very quite simple and easy example. Now let us move on to the next example. If A and B are independent events, what he is given? If A and B are independent events, that is given A and B are independent, therefore P of A intersection B according to independent formula, that is a P of A into P of what we have, that is B. Very simple. Now we shall move with the first one, and given P of A is equal to 0.3 and P of B is equal to 0.4. The first one, P of A intersection B, that is nothing but here P of A into P of B. P of A, the value will be 0.3, and dear students, P of B value, that is 0.4, and the value 3 4s are 12, that is 0.12. That is our required result here, that is P of A intersection B. Okay, dear students, now let us move on to the second one. Second one is P of A union B. A union B means what we have, that is a P of A union B equal to P of A plus P of B minus P of A intersection B here. Now P of A value, that is 0.3, P of B value 0.4 minus 0.12. Now what we get the value, that is nothing but here 0.7 minus 0.12, that means what we get here, that is 0.58 value, 0.58. What is the value? That is 0 P of A union B, that is the second one, P of A union B here. Now let us move on with the third one. What is the third one question? That is nothing but here P of A bar B, that is nothing but our conditional probability. According to the conditional probability, P of A intersection B divided by P of B here, according to formula. P of A intersection B means what is the value? 0.12, and here P of B value, okay dear students, that is nothing but here 0.4 here. So according to the formula, 4 3s are 12, that means the value will be 0.3 here. The value for that is P of A bar B here. Very, very simple. At last, the fourth one. The fourth one, that is P of B bar A here. P of B bar A means again same formula, conditional probability, P of A intersection B divided by P of A here. Okay, P of A. P of A intersection B value is 0.12. P of A value given in the data, that is 0.3. So here we get here after dividing 3 4s, that means 0.4 is the required value. That is the answer for our, that is the fourth part. Okay dear students, so these are the problems. So before going to the next problem, please pause the video to note it down. Okay dear students, now let us begin with the next problem here. The next problem is also very simple as compared to the last one here. Only the difference, that is if A and B are two events such that P of A equal to 1 by 4, given P of A is equal to 1 by 4, P of B is equal to 1 by 2, and dear students, one more thing he has given, that is P of A intersection B is equal to 1 by 8 here. Okay dear students, it is nothing but our 1 by 8 here. These all three values are given. Find not A and not B, that is given P of not A and not B here. That means P of not A means it is nothing but A complement, and means it is always intersection, and not B means it is B complement here. Okay, we are knowing one rule, that is by De Moivre's law, that is A dash intersection B dash equal to A union B whole dash here. That property will make use here. Okay, that is we know that by De Moivre's law. Okay, that is by De Moivre's law that you have studied in the first PUC set theory chapter. According to that, what I can write, P of A union B, okay, that is nothing but here whole dash here, P of A union B whole dash. Now here one more property we are having, that is nothing but 1 minus P of A union B here, because P of A plus P of A dash equal to 1, that means P of A dash, that is nothing but 1 minus P of A value. That already we had learned in the first PUC probability chapter. Okay, that is because result. Now A union B, A union B, do we know the value for A union B here? We don't know the value for A union B, but here dear students, 1 minus, we are according to the addition theorem, that is nothing but P of A plus P of B minus P of A intersection B here. And here all these three values we are knowing, that is P of A, P of B and P of A intersection B. What we get, that is 1 minus P of A value, the value is 1 by 4, 1 by 4 plus of 1 by 2 minus of 1 by 8 value. Now I will simplify here. So what we get, 1 minus 1 by 4, okay, plus 1 by 2, that is nothing but 2 plus 4, that is 6 by 8. Okay, 6 by 8, the value will be 2 3s are, 2 4s are, that is a 3 by 4 minus 1 by 8. At last, here also we can solve it and simplify the value. So now I will take directly, I will solve it, that is 1 minus 3 by 4 plus 1 by 8 here. Here we know that the LCM will be 8 here, okay, that is nothing but here into 8 here, the value will be 8 here, minus here 4 2s are, that is 3 2s are 6 it is, and here 1 here, it is plus here. Now what we get, 8 minus 6, that is 2, 2 plus 1, that is 3, 3 by 8, and that is nothing but our required result. And that value is for what? That value is for, the value is for 1 p of a dash and b dash, that is nothing but here 3 by 8 here. We are making use of the De Moivre's law as well as the some conditions of your probability that you had learnt in your first PUC syllabus. Okay, dear students, now let us move on to the second problem. The second problem is as simple as the previous one here. If a and b are such that p of a is given, okay, dear students, p of a is equal to 1 by 2, p of b is equal to 7 by 12, and p of not a and not b, that is very important, p of not a or not b, that is nothing but p of not a means a dash, or means it is union, and p dash, that is nothing but the value is 1 by 4. Just I will manipulate according to De Moivre's law here. Okay, also we know that a dash union b dash, that is nothing but a intersection b whole dash, dear students. That means here a dash union b dash, the value will be p of a intersection b whole dash. Okay, a intersection b whole dash. Okay, so here that value is nothing but 1 by 4, dear students. Now here whole dash means according to this particular property, p of a dash equal to 1 minus p of a, according to this property 1 minus p of a intersection b will have, which is equal to 1 by 4. You take this value that side, that means p of a intersection b equal to, okay, 1 minus 1 by 4, okay, and p of a intersection b, 1 minus 1 by 4, that is nothing but here 3 by 4 value, 3 by 4 here. Now dear students, what is the next question? State whether a and b are independent. To show that it is a and b are independent, that is a and b are independent if, that is nothing but p of a intersection b equal to p of a into p of b here, p of a into p of b. Now already we got the p of a intersection b, the value is 3 by 4. Andre ಏನು ಬತ್ತು ನಮಗೆ ಇಲ್ಲಿ, that is a 3 by 4 equal to p of a value given in the question, 1 by 2 into p of b value is 7 by 12. The value will be 3 by 4 equal to what we get here, 7 by 24, and that is not equal. Not equal means what it is, p of a intersection b is not equal to p of a into p of b. That implies a and b are not independent. Are not independent. That is nothing but our required result. Very, very simple and easy result here. Okay, dear students, now let us start with the next problem. The next problem is also as simple as the previous one. Given two independent events A and B. What is the first sentence? A and B are independent. A and B are independent. Independent means what, dear students? That is P of A intersection B equal to P of A into what we have? That is P of B. Very simple. Finished. Then such that P of A is equal to 0.3 given, P of B equal to 0.6. Find what it is, P of A and B. P of A and B means what? A intersection B, and means what? Intersection. So now since A and B are independent, that is a P of A into P of B, the value will be 0.3 into 0.6. 0.3 into 0.6, that is nothing but here 0.18. 6 3s are 18, that is 0.18 value. Next, the second one, very, very simple problem it is. Second one, what we get? P of A and not B. What we have? That is a P of A and not B. That is nothing but P of A and means intersection, not B means B dash. We are having one more property in the set theory. What it is? That is A intersection B dash. That is nothing but here A minus of what it is? A intersection B here. Okay, that is A minus A intersection B. I can also write here. That means according to this probability here, that value is P of A minus P of A intersection B here. Now P of A value. What is the P of A value? That is 0.3, and P of A intersection B value, just now we found, that is 0.18. Okay, and you can find out the result. You multiply it and you can find out the required result. That is 8 is a 24, 2 here, 3 2s are 3 1s are 3, 4 5, that is 0.54. That is the value for what it is, P of A and not B. Similarly, P of A or B. How to find this A or B? I will just give the hint here. That is third one. You can take it as homework. P of A or B means P of A union B equal to P of A plus P of B minus P of A intersection B. Or means what? Union. That's all. And means intersection. You are knowing P of A, P of B you are knowing, P of A intersection B also you are knowing here. You can substitute the values and find out the answer. You can take it as homework. At last, the fourth one, dear students, it is also very simple. Neither A or B. Neither A nor B means what? That means not A and not B. It means not A and not B, it indicates. So neither A nor B. That means both are not there. So here that is nothing but A dash intersection B dash means A union B whole dash. According to De Morris property, that is nothing but 1 minus P of A union B. So now A union B, just now you find out the value. That thing you can substitute here. Neither A or B means not A and not B. Both are same meaning. Okay, neither A or B means not A and not B. Okay, dear students. So this is all about our, that is nothing but exercise number 13.2. In the next class, one more session we shall discuss about this 13.2. Till that, thank you.